Have you ever heard someone say that when we look at space, we're really looking back in time? What exactly does this mean? How far back can we see?
Imagine someone sends their friend a picture of their newborn baby. The picture takes a month to get there, so when the friend sees the picture, the actual baby will be 1 month old. Now imagine the person sends a new picture of their baby every week. The friend is now receiving a stream of pictures that were each taken a month before she received them.
This is what we mean by seeing back in time. The light from the farthest objects takes billions of years to reach us, which means that when we look at them, we're seeing billions of years back in time, when the universe was still very young. But there's still one thing we need to consider: the expansion of the universe.
Imagine the friends live on opposite sides of a transverse fault and are moving away from each other. The one friend keeps sending baby pictures every week, but the other friend doesn't get a picture every week because each one has to cover more distance than the last.
This is the same idea as what's going on in the universe. Light travels with a constant speed and it's not instantaneous, which means that it takes some time for it to get to us. But at the same time, space itself is expanding. Just as the friends got farther and farther apart from each other because of the fault line, we're getting farther and farther away from everything else in the universe because the universe itself is expanding.
Think of it like this balloon. As it inflates, the stars get farther and farther apart. None of the stars get closer because the material itself is stretching out and expanding.
As this happens in the real universe, the light that was on its way to us from another object actually stretches out. We call this redshift because light with longer wavelengths looks redder.
Think of the points on this redshifted light wave as the baby pictures sent to the friend. At first, they come closer together, but then they come farther apart. Observing redshifted objects is one of the ways we know the universe is expanding. Something called Hubble's law tells us that the farther away something is from us, the faster it is receding. To calculate the recessional velocity, you need proper distance and something called the Hubble constant, the rate of expansion of the universe.
But despite its name, the Hubble constant isn't really a constant, at least not for the whole history of the universe. There were different periods of time when the universe expanded with different rates. Early on, there was a period called inflation, when the universe expanded tremendously fast in a very short amount of time, and at other times it expanded more slowly.
Here is a diagram of the history of the universe. Notice how scientists have split it up into different periods. One of the primary science goals of the new James Webb Space Telescope is to look at first light and reionization, a period just after the Dark Ages when the first stars and galaxies began to form.
The study of the history of the universe is called cosmology. From the moment it was formed to the present day, the universe has been full of fascinating wonders and phenomena that we want to understand. Historians and archaeologists have to piece together clues about our past from the evidence they find. Isn't it neat that to learn about the universe's past, all we have to do is look?